Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in the Department of Computer Science Engineering in Institute of Aeronautical Engineering, Hyderabad. So in this video, I'm going to discuss about minimum spanning tree, which is going to be solved through Kruskal's algorithm. So in this one, the minimum spanning tree definition have to see, and then how we're going to solve this minimum spanning tree through Kruskal's and then Prim's algorithm. So what is minimum spanning tree? So the minimum spanning tree of a graph is just a subgraph that contains all the vertices, and it is a tree. A graph may have many spanning trees. Okay, so a spanning tree of a graph is nothing but a subgraph that contains all the vertices, and it is a tree as well. And a graph may have many spanning trees. Suppose if I'm going to consider this is the graph here, so this is the one of the possible uh, subgraph what I obtained from the original graph, and this is the another subgraph what I obtained from the given graph. So this and all will be considered as a spanning tree of the given graph, and this is the another possibility of the subgraph obtained from the original graph. And this is the other possibility. Like this, we are going to be construct so many subgraph. So this and all will be considered as a spanning tree of the graph. So for this, the complete graph. So what are the possible combination of the all the spanning trees here? So this is the one of the possibility. So this is one possibility of the graph, and this is the second one, and third is the third category, and this should be the fourth one, and this should be the fifth spanning tree of the given graph, 6, and this is another possibility, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So if the number of vertices is 4, so the total number of possibility what I'm going to is 2 power 4, that should be 16. Suppose if I'm going to consider another graph, so take another graph here. So this is the graph I'm drawing. So what are the possibilities I'm going to get here? So this is one possibility. This is another possibility. This is another possibility. So like this, you can able to construct so many subgraph from the given graph. So the total number of vertices is 3, so I can able to get 8 possible combinations. Similarly, this is the number of vertices in this one is 4, so that's why 2 power 4, that should be 16 possible spanning trees I can able to obtain from the given graph. So this minimum spanning tree of the given graph is the spanning tree of the minimum cost for the graph. So if I am going to have a graph with the weights, so the minimum spanning tree means that the sum of the weights of the graph should be minimum here. So how are we going to obtain this minimum spanning tree through Kruskal's algorithm? I will explain now. So for this given graph, suppose, so this is the graph what I'm having now. So in this one, the minimum spanning tree what I'm going to be constructed here, that should be minimum 1 in such a way that the sum of all the edges weight should be minimum. So that is the problem of minimum spanning tree. So for solving this problem, I'm going to follow two types of algorithms. So what one able to call it as Kruskal's algorithm, and second one is Prim's algorithm. So in Kruskal algorithm, so we're going to construct it. You'll see now. So this algorithm is going to create a forest of trees. So initially the forest consists of n single nodes, trees or n edges. At each step we are going to add on one edge that should be the cheapest one so that it is going to join the two trees together. So if it will form a cycle, then it would simple link two nodes that were already part of single connected tree, so that the edge will not needed here. So in this Kruskal algorithm, so the algorithm is going to create a forest of trees in such a way that uh, and we go on adding and one edge, so that should be the cheapest one, and it does not form a cycle here. So once this forms a cycle, then the edge is not going to be added in this tree. So in this example, how this one is obtained here is according to Kruskal's algorithm. So first initially we have to be drawn all the edges of the graph, and for then we have to identify what is the minimum edge here, one, so that one should be considered, and what is the next minimum edge, two, so two is drawn, and next minimum edge 3, so 3 is drawn, and next minimum edge 4. So if I'm going to construct 4, it is going to form a cycle here, right? So that's why what will happen, I will not construct this edge. And similarly, if I'm going to take 5, so again the loop is formed, right? So that's why I will not construct this edge also. And next one is 7, so 7 if I'm going to take, this one also forms the edge. So from the cycle, so that's why this will also not be considered. So the total minimum spanning tree for the complete graph is 1, 2, 3. So according to the Kruskal's algorithm. So what are the steps you have to be followed here is that, so first the forest is constructed with each node is separated in the tree. Then the edges are going to be placed in priority queue until we have to add on n minus 1 edges. So extract the cheapest edge from the queue, and if it forms a cycle then reject it, else add it to the forest. So adding it to the forest will join the two trees together. So every step will have joined two trees in the forest together, so that at the end there will be only one tree in the tree. So the forest is going to be constructed with each node in a separate tree, and the edges are going to be placed in priority queue. Okay. So then we have n minus 1 edges in such a way that we have to extract the cheapest edge from the queue, and if it forms a cycle then we have to reject it, otherwise we have to add it to the forest. So adding it to the forest will join the two trees together. So every step we have to join two trees in the forest together, so that at the end there will be only one tree in the tree. Suppose this is the complete graph what we are going to have. So for that we have to be construct the minimum spanning tree for the given graphs. So according to the Kruskal's algorithm. So for this, so what are the steps we have to be followed? We have to please construct now. So among this one, so what is the first minimum? So in reality, they should be placed in priority queue, so not sorted. So but sorted them makes the algorithm easier. So that's why initially these are the edges and weights I'm going to have 4, 10, 6, 3, 3, 2. So these are all the edges and initially. So in order to make the algorithm simpler, so what we have to do is, so we have to be sort all the edges according to the weights in sorting order. So once we have to be done this, then all the edges will come into the sorting order now. So now fill one by one. So whether this one is going to be formed a spanning tree or not. So what is the first one here? AD. So consider AD first. So since this is the first minimum value, and the next minimum value in the tree is CF. So CF I have drawn. And what is the next minimum weight? CE. So I have drawn CE also. So it does not form a cycle. And next minimum edge is EG. So EG is also drawn. And next minimum edge is 2. So that is HJ. and then next minimum edge is FG. So if while forming this FG, so I'm going to get a cycle here. So that's why this edge is going to be eliminated. So that means we should not consider this edge. So the next one is GI. So GI. So this is the one. So this edge not be considered. And next one we have to see as GI. So GI is going to be considered here. And next one is IG. So no closed loop is obtained. And AB. So no closed loop is obtained. And next one HBD. So the loop is obtained here. So that's why you should not consider this edge. And next BC. Yeah, the loop is not closed. Next JJ. So the loop is obtained. And FI. JJ. Loop is obtained. So will not consider. And HI. So the loop is obtained. So not remove it. And DH. So the loop is obtained. So not considered. And DJ. So DJ also loop is obtained. And DJ. So will have to be considered. So we'll not consider this one also since it forms a cycle here. So finally this should be the resultant spanning tree obtained for the given graph. Okay. So in this video I discussed about how we're going to construct the spanning tree here. So the spanning tree of the graph is nothing but a subgraph where it should contain all the vertices, and graph may have many possibilities of spanning trees. And so if I'm going to consider a spanning tree, so what are the one more possibilities I'm going to get it is 2 power n options. So for the given graph, the number of vertices is 3, then I can able to get 2 power 8, that means 2 power cube, that should be 8 possible combination of spanning tree I can able to get. If the number of vertices is 4, then I can able to get 2 power 4, that is 16 combination of spanning trees. If it is 5, so 2 power 5, that should be 32 combinations of spanning trees I can able to get. So for the minimum spanning tree, so there should be an algorithm for this. So Kruskal's algorithm we are going to be constructed. So very first thing is that first we have to be construct the forest here. So in this one, the edges are going to be placed in the priority queue. So then until we are going to get n minus 1 edges, and then extract the cheapest edge from the queue, and then forms checks whether it is going to be form a cycle or not. If it is going to be form a cycle, then reject it, otherwise add it to the forest. So this is the given graph I told, and initially I'm going to be wrote all the edges according to their weights. Then after that I'm going to sort all the edges in the increasing order, so that I have to take the first minimum weight, and then I have to fill that matrix. So what is the minimums, and I have to check parallelly whether I'm going to get if any cycle is obtained or not. If the cycle is obtained, I have to be eliminated. Then this should be the resultant spanning tree of that given class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.